edition of our Two Medicine Voices speaker series. And for those of you who are visiting, welcome to East Glacier and the Blackfeet Nation. We're really glad to have you here and hoping you're having a very wonderful time, whether it's in the park or on the reservation or forest lands or whatever it is you might be doing. My name is Peter Metcalf, and I'm the Executive Director of Glacier-Two Medicine Alliance. We're a local conservation group based here in East Glacier that's hosting tonight's talk by Chris Downs. And our organization is dedicated to the protection and stewardship of the land, waters, and wildlife of a really special area called the Badger-Two Medicine, just south of here, as well as some of the adjacent areas, including the park here in Montana's Crown of the Continent. We got founded in 1984 by Blackfeet tribal members and non-tribal residents here in East Glacier who were concerned about imminent oil and gas development slated for the Badger-Two Medicine. And after nearly 41 years of tenacious fighting, lots of partnerships, Blackfeet leaders and other conservation groups, we finally succeeded in eliminating the last oil and gas lease in that area last year. So it's a pretty exciting thing for us as an organization. Our work continues to protect that land, try to get some sort of long-term durable protection, improve Blackfeet code stewardship for this area that is sacred to them, as well as to work on other management issues related to the lands here in the Crown, including in the park. One of the things we're focused on a lot is local recovery of native species, both terrestrial wildlife like grizzly bears and mountain goats, but also fisheries, as Chris is going to talk about tonight. And have been involved a little bit in one of the projects I think he's going to highlight on the east side of the park at Gunsight Lake. One other thing I want to flag before I introduce him that we're also working on a lot right now during this time of the year is fighting invasive species. It's a real problem around here, especially with climate change. We've got a lot of, we're focused particularly on noxious weeds, reducing wildlife habitat, and creating other issues. And so if you're around next weekend, we're having our annual community Badger-Two Medicine Community Weed Pull at Education Day. And so I encourage you to come and join us. We'll be meeting here at 9 in the morning and then going out into the Badger to pull weeds and give back to the public lands as part of your time or travels here. It would be amazing to have you. Afterwards, I encourage you to stop by our information booth. You can sign up if you want to learn more about our work or upcoming events we have this summer. Sign up for our email list, or you can pick up a t-shirt in the back or make a donation if you want to support our work. But tonight I'm here to introduce Chris Downs. Chris, we're very excited to have you here. Thanks for making the trip to present about the work that you do. Chris is the Aquatic and Physical Sciences Program Manager for Glacier National Park. So he kind of oversees all the stuff that has to do particularly with fisheries in the park. He used to work for a long time prior to his current position as a fisheries biologist in Glacier. So if you have a question about fish, Chris is a good one to ask. The park, of course, is home to a number of native species that he's going to highlight. Most notably, West Slope cutthroat trout and bull trout, which is a federally protected species. Before that, Chris worked in the state of Idaho, mostly up in the Panhandle, working on a lot of different fisheries projects in the Kootenai and the Lower Clark Fork. And he graduated with his MS from Montana State University a little while ago. And I guess got to say go Grizz, as a U of M alum. So, but
the junior college, right?
As well. So, we're very glad to have you here tonight. We're very much looking forward to hearing about some of the work that you're doing and the park's doing to try to protect our aquatic resources and to restore some of our native fisheries in the park. So let's give it over to Chris.
Well, thank you, Peter, for that nice introduction, and I appreciate everyone being here. I always enjoy talking to folks. It's always nice to talk to visitors who have made it their objective to get here and be in this special place. I'm going to touch on some of the work we've been doing. I've been here 16 years now, and I'm responsible for aquatics and physical science, and I'm going to touch on physical science as well. There's some interesting stuff going on. Just to introduce our program, so from a physical science perspective, we're in charge of monitoring air and water quality across the park. We participate in 6 fixed location and 2 mobile monitoring systems that are nationwide systems. And Glacier is an important data point because we're in a protected area. We also conduct investigations related to air and water quality concerns. So if we have a concern raised or we see a problem in a watershed, we'll do a study to evaluate what the issue is and what can be done to remedy it. From the aquatics perspective, as Peter mentioned, my work group manages fisheries, but also aquatic invertebrates and amphibians. And some of the more practical work we do is the park is always managing infrastructure and building infrastructure and so forth. And we help them do that in a way that is fish friendly, water quality friendly, and so forth. So that's our sort of how we work as a team with our facilities folks and so forth. And recently, aquatic invasive species prevention that Peter also mentioned has also come under our work group. So if you have any boats that you're bringing to the park, they need to be inspected and permitted before they can go on park waters to make sure they don't bring invasive species to the park, particularly zebra and quagga mussels. So we run the inspection stations with the Blackfeet, in partnership with the Blackfeet, and we also do the early detection monitoring. So a couple weeks ago, I was out sampling all the lakes, collecting water samples, and those water samples can be tested for tiny DNA molecules that would give us a clue to whether we have invasive species without actually seeing them, part of an early detection program. So I'm going to kind of go in order here. So here we are. I have to push the wrong button. There's Glacier. These are all the different national parks that participate in these large-scale air quality monitoring programs. And at Glacier, we're looking at things like ozone, which is important for human health, but also for visibility. Glacier and a lot of national parks are considered Class 1 airsheds. It's not permissible to have activities that reduce visibility. That's one of the magnificent things about some of our national parks, the views, right? Grand Canyon and so forth. So we consult with the state of Montana when they're going to permit a new power plant, something like that, to help mitigate some of those impacts so we're not losing visibility. And then more practical things like nitrogen, sulfur, and mercury deposition, things that affect the acidity of water and soils, because that's sort of the foundation of our ecosystem, and particulate matter and smoke, which is becoming more of an issue in our area. When I came here, I was really used to having clear summers. And when I first got here, the geographer joked that he called it the asbestos forest, but that's no longer the case. We have more frequent wildfires, so smoke is more of an issue. This, for folks that are interested in knowing what the air quality is like in the park, this is called, it's a Purple Air Network, map.purpleair.com, and these are sensors that we have across the park, and anyone can go in at any time and just pull up that map and see what the air quality is like, and then correlate it to a chart of standard air quality health. So it's a really practical thing if you want to know, if you're going to come from the west side of the park and you want to know what the visibility is going to be like when you get to Mini Glacier. Aside from the webcams that are not always functioning, you can look at this map. Similarly, another interesting tool that's out there for folks is this fireairnow.gov. And you can zoom in and it's going to show you where all the fires are across the United States. And it also shows you the smoke plumes, right, that are coming from these fires. So if you're wondering where your fire smoke is coming from, you can go to this website and you can actually zoom in and see where your smoke's coming from.
What's the website?
It's fire.airnow.gov. And again, it's a publicly facing website, so anybody can go use this for any part of the country. And it even has parts of Canada in it, which is of interest as well, given all those wildfires that were affecting the United States last year. So I talked about our monitoring network. We also do, as I said, research and to understand what's going on with with our water quality in this particular case. So sort of a case study here. This picture here is probably one of the most photographed points in Glacier National Park. It's from the foot of Lake McDonald looking at the beautiful rocks. Everyone needs to get a picture there when they go there. And our water is known for being really clear, really pure, if you'll have it that way. Not a lot of nutrients in it, and that's what makes it clear. We have low productivity. We're called oligotrophic, which has, it's very high water quality, essentially. So we're concerned when we start to see nutrient inputs that could change that, because in practical sense, you're going to lose visibility when you get more productivity. Like some people live in areas, I used to live on the East Coast, and you can put your hand in the water and it disappears after a foot or two. Tannins or whatever's in the water doesn't mean it's polluted, but it's just different. We don't have a lot of nutrients in our rocks, and therefore we have low productivity waters. But we had some concerns from some folks that live around Lake McDonald. Lake McDonald is interesting because there are people that own private lands around Lake McDonald, and they were there before the park came into existence. And some of these houses aren't on sewer, they're on septic. So the concern is always, can septic get into the waterways? That's a concern. So we had some landowners, some folks from the community come to us and say, we're concerned about water quality in Lake McDonald. What can you tell us about it? And I looked back and I said, well, the last time we did a study of water quality in Lake McDonald was 1990. And this was 2020. They were asking me what's going on in Lake McDonald. So we decided it was time to prioritize doing a basic survey of water quality in Lake McDonald. And what we came back with was fairly alarming. Phosphorus had increased like tenfold from the 90s. And phosphorus is what limits productivity. It's going to spur algal growth. The question is, you only have 2 data points. You can't really say much about what's going on with the trend or what the sources are or what the timeline is of that. So we decided to go back and work with the Flathead Lake Biological Station and they're experts on water quality and see if they could help us understand better what's going on with Lake McDonald. Is it due to the fires? We've had more fires around Lake McDonald. That's certainly one possible option. Is it nutrients coming from increased visitor use? Is it septic systems? What is it? So the objective is to build a contemporary and historic nutrient budget to understand what's going on with productivity. So from a practical sense, we took it one step further and we took some lake sediment cores. So you go up out in the middle of Lake McDonald, for example, and these guys are from University of Regina in Canada. They're experts at this. And this looks like a pretty crude instrument. I teased him that he should be using these to work out, not use them for weights on his core device. But basically, you have to drop that over the side of the boat. You got to be really stable. It's going to go straight down. And he's going to know how deep the water is. And then he's got to feel it like 400 feet down just when it touches the surface of the sediments. And then slowly let it go down further. So it takes a perfect core, not a horizontal core. So if you can think about all that's happening, 450 feet down in the water, you got to be pretty good at what you're doing. And then he sends a messenger down on a rope that hits the top of the device. It takes like 3 minutes for it to get down there. And it closes a vacuum on top of the cylinder. And then you can pull it up and then you have mud, basically, that's accumulated in the bottom of the lake over time, this being the oldest and this being the newest stuff. So you think what we can do with that, we can turn it upside down and you can take 1/2 centimeter slices of that, put it in a bag, it'll be dried, and then you can assess the nutrient concentrations back hundreds of years, essentially. So we can get a long-term picture of what's going on, not just the past 20 or 30 years. And I think we're trying to take this back. We're trying to take this back to the Industrial Revolution, basically 1850, because that's when likely things got going from any sort of an airborne contaminant perspective. And that's
How do you know the rate of settlement?
You can date these the same way you date a lot of other things. And for this, you can use radiation. You can use the testing of nuclear devices when that was going on to basically set a date for when, because you can find that in the sediments and you'll know what date that is. The trouble is, we can't go beyond that using that methodology because it only takes you back to about 1910. That's just how it works out, how the math works out. So in order to do that, which is what we want to do and what we got some funding from the Conservancy to do, we want to look back, like I said, to 1850. And you can use pollen. So we're drying this stuff and sending pollen to Woods Hole Oceanographic Institute, and they'll be able to date the rest of the sediment core. I can't tell you how they do it exactly, but I'm happy enough that they just tell me they can. I'm going to have some faith in them.
What's magical about 1850?
It's about Industrial Revolution, just when we would expect some sort of human signature or something like that to have occurred. It's nothing magical at all. It just seemed, when things really got going and you could start to see some impacts from industrialization or development. There's nothing magical to it. Moving on to fisheries. So we sit at the top of one of the only 2 triple divides in North America. One here in Glacier, and there's one in Canada as well. So what that means is we sit at the top of the Hudson Bay drainage here, and that water's flowing all the way from basically Logan Pass at St. Mary all the way out to Hudson Bay, which, depending on the tides, is going into the Arctic Ocean or the North Atlantic Ocean. We have the top of the Missouri system here, the very tip top of the Missouri system, which is, of course, going into the Mississippi and down into the Gulf of Mexico and Atlantic Ocean. And then we have the flathead systems, North Fork and Middle Fork. And that stuff's going up the Columbia to the Pacific Ocean. And as a result, it's a confluence zone of where fish could get over time as they moved around in their own systems, not being able to move across the continental divide, except with episodic events that would have likely have happened immediately post-glaciation. So we're not, as I said, we're not particularly old here from an evolutionary perspective. We've only had 4 species that have evolved in the trout and salmon family here. And a lot of that's due to glaciation. We were covered in ice 10,000 years ago. Not a lot of time for evolution compared to like the Southeast US where you have hundreds of species of minnows. There's a lot of time for species to evolve and develop that way. So we have the state fish, the West Slope cutthroat trout, named after Lewis and Clark, Oncorhynchus clarki lewisi. Bull trout, which is actually a member of the char family, not a true trout, but it's a member of the family. It's a top-level predator across the park. Mountain whitefish. Sometimes we refer to them as the Rodney Dangerfield of the trout and salmon family because when you get them on the line, people see what they are, they're just disappointed. They don't get any respect, right? But they're a fun fish to catch. And then this is their cousin here, the pygmy whitefish. The pygmy whitefish is a smaller cousin of the mountain whitefish, and they're small. This is like state record size. That's a proud young man right there.
So those 4 fish are the only species that are in the park?
Members of the trout and salmon family in the flathead on the east side of the park. I kind of color coded this. So this is the green, so this is going to be the flathead. You'll see the other colors come up. So these are the only members of the trout and salmon family. There are a couple of minnow species. There are 2 sucker species, but it's not a lot of native species when it comes to fish. And it gets even fewer as I get into the rest of the drainage of the park. Hudson Bay, as I said, it's draining a huge area of Canada. And you're talking about almost the Arctic, a whole huge assemblage, everything north of the United States headed out that way. And we have some of the same species. We have still have the West Slope cutthroat trout. We still have bull trout. We have mountain whitefish, no longer pygmy whitefish, but it gets really interesting because of that huge expanse we're draining into. So, native lake trout. That's strange because lake trout are giving us fits on the west side of the park, replacing our native bull trout, but they're native to this drainage here. And bull trout and lake trout have had thousands of years to work out their differences, and they haven't had that time on the west side of the park. So native lake trout enter the picture. Native lake whitefish enter the picture as well. And then this guy. This is a burbot. It's the only freshwater member of the cod family. You can see it's got a median barbel right there. It's got a circumpolar distribution, and it's a really amazing fish. It's a top-level predator too, and the only place in the park you're going to find them, and it's one of the only places they're native in Montana, is in the St. Mary River drainage. Missouri River drainage only has 2 native salmonids, and that's where we are right now. We have the West Slope cutthroat trout and mountain whitefish. And in fact, if you enter the Two Medicine area of the park, right where you cross Two Medicine River, after you enter the park, there's a pullout and there's a waterfall there. There are no native fish above that point. So all those lakes up there were historically fishless. So that's part of the reason we have fishing regulations that allow unlimited harvest of fish above those falls, because they're all non-native anyway. And we have brook trout and lake trout that have been introduced up there. So Glacier has most of the physical habitat at Glacier is intact. We don't have timber harvest. Very little mining has occurred in the park. We just don't have the sort of problems that happen, or the sort of management issues that can arise outside of a completely protected landscape, and it's really diverse. We have these small high mountain lakes. We have large lowland lakes. We have small streams. This is quite common on this side of the park. As the glaciers retreated, they left these hanging valleys, so there's not a lot of habitat for native fish to use because they're blocked by waterfalls. And then we have larger, this is actually Nyack Creek, but I guess where I grew up, that would be a river. It's a pretty good sized creek. And the point I'm making here is all this diversity on the landscape has really fostered an incredible diversity in individual species within the park, and that's what makes the park of such great conservation value to a species like bull trout. So this bull trout's from the St. Mary. It migrates from St. Mary River up into small streams in the park to spawn because it can do that. That's called a life history. This little guy here is another adult bull trout, and it's found in that glacially fed lake that I just showed the picture of. That's Cracker Lake. The only species in there is, that's a bull trout. All 3 of them are bull trout. That's what I'm saying. They've evolved in these different habitats, and they've had to adapt to them. And it's this amazing diversity you can't find anywhere else in the range of bull trout. He's all slate colored, and it's hard to even imagine how they make a living in that lake because there can't be much productivity there, very few insects. They're obviously not eating a lot of fish because they'd be bigger. And this guy is from a small clear lake on the west side of the park, Isabel Lake. And it's got these beautiful pumpkin colored fins. It's just a beautiful fish, but they're only like 12 inches long in there. And in fact, the cutthroat trout are larger than the bull trout in there, which I've never heard of anywhere. And what's important here is it's this kind of diversity that, diversity is stability in a lot of senses in natural systems. And it's this diversity that is going to help these fish adapt. It's their adaptive capacity going forward, basically, in the face of a changing climate, essentially. So it's a valuable bank of genetic diversity for the species. And in fact, Glacier has 2/3 of the natural lake areas that have supported bull trout. 2/3 of the lakes are found in the park in their range of the natural lakes. The bull trout, the big bull trout are eating fish. That's how they get big. They're eating other fish. The fish in the St. Mary Lake system.
Just minnows or whatever is that there.
Anything smaller than them. I'm not kidding you. They'll eat a fish that'll be half their size. Their tail will be coming out of the tail will be coming out of their mouth. I put a little bull trout in a bucket with a little brook trout, and he immediately started chasing it around, grabbed it. They are aggressive predators. That's what they do. But there are threats, and climate's out there, but it's not something I can manage at a local level. These are big issues that require big solutions. But we can't just sit on our hands and not try and address the problems that can be addressed at the management level. So a couple of things here to note. So the things that are really gonna affect these fish, they are cold water obligate species. Bull trout have the coldest thermal optimum of any inland salmon in the United States. They require the coldest water. And as you warm that water, it becomes less suitable for them for habitat. And we know, all the models predict, and we're seeing in our own data, that the water temperatures are warming. Increased forest fires, changing the riparian vegetation on the landscape. We're seeing more dewatering as we get more rain than snow in our snowpack. Late season, bull trout spawn in the fall. They can't get to their areas if they're dried up because of the snow melted earlier and there wasn't enough snowpack. And also with warmer, wetter winters, we refer to as rain on snow events. So basically, you've got frozen ground, 2 feet of snow on the ground, and then you get 10 inches of rain on it. And it becomes like a parking lot that you just put a hose on the water and it basically scours the beds. This is the historic 64 flood. It's never been higher than that. And that actually is the bridge going over the Middle Fork, just upstream of the Park Bridge. It should be, and it was completely washed away essentially. So rain on snow events, and what they'll do is they'll scour out, the bull trout spawn in the fall. So those eggs are sitting in the gravel and this occurs and you lose those eggs. So they're vulnerable to this. It doesn't happen all the time. And historically, if this wasn't a trend, they evolve with it, they can deal with it. But if it's happening more and more, that's gonna be a problem. The things we can control are what's going on with invasive fish. This is a practical thing we can do at our management level. Basically give them a break. Try and deal with invasive fish, which are a near-term threat, and give them a chance to evolve to a changing climate, which is a near-term and a long-term threat. So we're taking management actions. This is some of the things that go on. So we have rainbow trout expanding in the park as water temperatures warm, and they're hybridizing with cutthroat trout. And we also have brook trout that are hybridizing with our bull trout. And part of the problem there is when a bull trout and brook trout spawn, they're sterile essentially. So you just have this big fish that's out there eating other fish, taking up space and wasting resources.
So the hybridization is naturally occurring?
No, these are introduced fish.
Yeah.
So the brook trout are introduced, lake trout are introduced on the west side of the park, and rainbow trout are introduced. Rainbow trout are a Pacific fish, brook trout are an East Coast fish. So they're brought to the park, pretty much put all over the United States, a popular sport fishery. It's worth a lot of money in Montana, rainbow trout fishing in southwest Montana and some places. But here, they have a negative impact because they're migrating up into our cutthroat streams, they're hybridizing with our fish, breaking down their local adaptions, and what you end up with is not a cutthroat trout anymore.
Who's putting them into the system, just people?
Yeah, we're not doing it anymore. We're not stocking rainbow trout in these areas anymore. But there's legacy issues. They're on the landscape. They were on the landscape for a long time. They were stocked. There were so many species of, literally hundreds of thousands of fish and eggs were stocked in Glacier Park of all different species. King salmon were stocked in Lake McDonald. Fortunately, they didn't take off. So now we're trying to manage these fish by removing the rainbow trout and reducing the genetic component of rainbow trout in some of these populations by removing the hybrids and removing the rainbow trout from the systems. In addition, rainbow trout are competitors with cutthroat trout, so they're kind of a double-edged thing. They hybridize with the bull trout and they compete with the cutthroat trout. And lake trout are just voracious predators, and they have an advantage in the park lakes. We have these beautiful, pristine, deep, cold water lakes, and anybody who's familiar with lake trout know that that's what they thrive in. In central Canada and north central United States. And they're top level predators, but they spawn in lakes. So they basically have unlimited spawning and rearing habitat in our lakes. Whereas our bull trout go up these streams. There's only so many beans you can fit in the jar, so to speak, in a stream in terms of little bull trout because they're territorial. And then you're subject to low water, drought, warmer water temperatures. There's definitely an advantage to being a lake trout as an introduced species.
So what do you fish them to get them?
Yep. Yep, we fish them. That's what we're doing for lake trout. And I'll get to that. I'll show you a couple of projects that we're doing. And this is what I'm getting at. Well, how do we deal with this sort of stuff? There's a bunch of different things. This is from another talk that I give, but it's basically, we need an all of the above approach when we're trying to deal with managing invasive fish. And there are several ways you can look at that logically, multi-pronged kind of stuff. The first thing is protect what you have. This is not without controversy. So we're building fish barriers in the backcountry in recommended wilderness. So Glacier is not designated wilderness, but it is recommended wilderness, and it's managed by policy as wilderness. And what that means is this generally, without another good reason, this would not be acceptable in a wilderness setting to go in and build a human structure there. But the good outweighs, in terms of our analysis, the good of preventing these fish from getting into the native fish populations proactively by building these fish passage barriers means we're not going to have to manage non-native fish in the future there, which is also an impact on wilderness. And we'd rather have healthy native fish populations and do this than have not healthy fish populations and have to go in and do something later. So protecting what you have first. And these are fairly low cost. It's amazing what our trails folks can do. Moving these logs by hand with pulleys and cables, these things weigh thousands and thousands of pounds, and building structures that are durable. So this is I'm going to get to Quartz Lake right now, but essentially, Quartz Lake that I'm going to talk about was the largest lake in the range of bull trout until 2005 that had only a native fish community in there, no non-native fish. It's really significant in the whole range of the species. So they built this fish passage barrier there to keep out the lake trout. The next year, the biologist was up there fishing and he caught a lake trout. So they were already above in Quartz Lake. We just hadn't found them yet. So we reinforced this barrier, and then we decided we're going to try and do something about it. We talked about suppression. Our goal was to eliminate lake trout from this system. We did some modeling. We had a graduate student on it, had some experts from the Great Lakes. And anybody familiar with Great Lakes fish biology knows that we were able to basically destroy a good lake trout fishery in the Great Lakes just by recreational fishing. Surely we should be able to destroy a lake trout population in a lake that's only 600 acres if we put enough pressure on them. But it hasn't turned out to be the case. It's more like keeping them from taking over your lawn, some sort of weed in your lawn. Keep them at a level where they're not taking over the system. You still have mostly a native system that's functioning like a native system, and that may be where we end up in the long term with some of these projects. And that's why we're going to do some different things that I'm going to get to in a little bit. So how do we get a boat in there? That lake is 6 miles from a road. So we had to fly in this 23-foot commercial gill netting boat that we had built, and we pack in all the gas, and we're just, every spring and fall, we're in there gill netting lake trout. Juveniles in the spring and adults in the fall to remove them, to reduce their abundance and keep lake trout at the level they were at before we discovered the lake trout in the habitat. So this is what our removals have looked like over time. We've taken out almost 11,000 lake trout. Their population is very small. We're having a